Hi, everybody. We are going to look at volume of cones today. So I think of a cone like an ice cream cone. You have a circular base and kind of like a point at the top. So that's how you can tell it's a cone. And so the formula for a cone is actually very much like a cylinder. The difference is that a cone is a third of a cylinder. So if you were to actually, I'm going to try and draw this on here. If you were to actually put three cones together, and I'm not going to do a very good job at this, I can already tell. If you were to put three cones together, you would actually get a cylinder. So it makes sense that our formula is basically the cylinder formula with a 1/3 out front. Okay, so again, you don't have to memorize this formula, but just so you know where it's coming from. And then just as a reminder, here's our different directions. Okay, so if it says to round, we're using the pi key. If we are asked to leave our answer in terms of pi, we're going to leave pi alone. And if it tells us to use 3.14 for pi, then that's what we're going to substitute into our work. Okay, so let's start just with kind of a basic volume question for a cone. So it says to find the volume of the cone and round your answer to the nearest tenth. All right, so first things first, we're going to write down our formula. And so because the directions say to round, that means that we are using the pi key. So we're going to bring down that 1/3. We're going to put pi in for pi. And looking at our picture here, we need to find the radius of that cone. So remember, the base of your cone is a circle. And so the radius of the circle is what goes halfway through, which is 3. So I'm going to do times 3 squared. And you can see the height of our cone is 6. Okay, so there are a couple ways to type this in your calculator. One thing you could do is you could use your ABC key to type in that fraction. So if you remember, we would do 1 ABC 3 and then times the pi key times 3 squared times 6. That's one way. The other thing you could do is you could type in pi times 3 squared times 6, hit enter, and then divide by 3. Okay, so those are the two ways that I would recommend figuring out your answer. And so make sure, try one of those. And if you did it correctly, you should be getting to the nearest tenth, 56.5 cubic inches. Okay. For the second one, it says, April is filling 6 identical cones for her piñata. Each cone has a radius of 1.5 inches and a height of 9 inches. What is the total volume of the cones? Round your answer to the nearest hundredth. Okay, so we have 6 cones that are all the same size, and I need to find the total volume of them. So what I'm going to do is I'm going to find the volume of 1, and then I will multiply that answer by 6 to get the total volume, or you could add them together 6 times. So let's start with our formula here. If we go back, it says that we are rounding our answer, which again means we're using the pi key. So I'm going to leave pi in my work. The radius, they tell me, is 1.5 inches. So this is times 1.5 squared, and our height is 9. So they give us everything that we need. Okay, so again, practice typing in this entire thing to your calculator, whether you're using the fraction key for 1/3 or whether you're multiplying it all and then dividing by 3. And we should be getting 21.2057. I'm just going to write out a bunch of numbers here. Okay. And again, we need to take that number and multiply it by 6 because there's 6 identical cones. And then our final answer, we are rounding to the nearest hundredth. So after you multiply by 6, we're ready to round 127.23 cubic inches. Okay, number 3. Find the volume of the solid to the right. Round your answer to the nearest tenth. So every once in a while, you guys will find that you're given a picture that is a combination of more than one 3-dimensional shape, okay? And basically, if you're asked to find the volume, you're just going to find the volume of each of them separately and then add them together. So that's exactly what we're going to do for this one. So there's two different cones here, okay? And then I'm going to find the volume of them separately and add them together. So I'm going to start with the top cone. So formula, and we're rounding again, so we're going to be using the pi key. So I'm going to start with 1/3 pi. Now the radius of that top cone, the one that's upside down, is 8. So I'm going to do times 8 squared. And the height of that cone is 16. All right, so 1072, bunch of decimals here. You guys are going to notice, I'm not sure if I said this before, that I am not rounding until the end. That's very important when you're working with these. If you round too soon, it could affect your final answer. So if we're asked to round, we round at the end of the problem. So that's why you see me putting a bunch of decimals here, so that I'm going out far enough so that when I do round, it doesn't affect my answer. Okay, so now I'm ready to find the volume of the bottom cone. Again, I'm plugging in pi, so I'm using the pi key. The radius of that bottom cone is the same, so 8 squared, but the height is 8. All right, so take a minute, type that in. I'm getting 536 point. Bunch of decimals here. Okay. So we are ready to find the total volume by adding these together. So again, it looks like I went out, 6 decimal points or decimal places. That's more than enough. So when you're adding these together, type that in, and we are going to the nearest tenth. You should be getting 16.08 or 1608.5, and that would be centimeters cubed. All right, number 4. Cone A has a height of 2 kilometers and a diameter of 7 kilometers. Cone B is pictured to the right. Which cone has the greater volume and by how much? Use 3.14 for pi and round your final answer to the nearest hundredth. Okay, so we do not have a picture of cone A, but we have the dimensions that we need, and we do have a picture of cone B. And so what we want to do is find the volume of each, state which one is more, and then by how much. Okay, so I'm going to kind of separate my work here. I'm going to do cone A versus cone B. All right, let me start with my formula for both. Just kind of getting this all set up real quick. Okay, now if you look at the directions, it does say use 3.14 pi, and then it says to round your final answer. So what that means is in our work for finding the volume, we are using 3.14, and then at the end, when I go to find the difference between them, because it wants to know which one's greater and by how much, that's when I'm going to be doing my rounding. Okay, so let's start with cone A. So 1/3, again, we're plugging in 3.14. Now it says that the diameter of cone A is 7 kilometers, which means the radius is half of that. So 3.5 is what I'm putting in. Squared times, and it tells me the height is 2. All right, so let's type that in. And it looks like we're going to get 25.643 repeating kilometers cubed. All right, so now we're going to do the same thing with cone B. So cone B is the one that's pictured. So 1/3, I'm using 3.14 for pi. Now in the picture, it's showing that 4 kilometers is the whole way across the circle. So that's the diameter. So the radius is half of that, so 2. So times 2 squared times my height, which is 5. All right, so let's type that in. And we should be getting 20.93 repeating cubic kilometers. All right, so which cone has the greater volume? So definitely cone A, and then it wants to know by how much. So to do that, we're going to subtract our two volumes. Okay, so when you guys are typing in, obviously we can't type in a repeating decimal, so I would just do 25.64333. I mean, that's totally fine. 20.9333. Because we are rounding our final answer to the nearest hundredth, going out that many decimal places, 4 or 5 decimal places, will be absolutely fine. And so the difference that I'm getting is 4.71 cubic kilometers. So let's answer this. So cone A has the greater volume. I'm going to say by 4.71 cubic kilometers. All right. Let's go to the number 5. If the volume of a cone is 1,441.26 centimeters cubed and its radius is 9 centimeters, find its height to the nearest centimeter. All right, so this is definitely something that's new to us, where we're not being asked to find the volume anymore. Now we're being asked to find one of the dimensions. Okay, so we did do this, I believe, with rectangular prisms where we had to work backwards. So let's do the same thing here. We're going to start with our formula for a cone. And what we're going to do is we're going to plug into that formula everything that's given to us. Okay, so we are given the volume. So I'm going to put that in place of V in my formula. I'm going to bring down my 1/3. They are saying to the nearest centimeter, which means we are rounding, so we're going to be using our pi key. They tell me that the radius is 9. And the height is what I don't know, so I'm just going to leave that as H. All right, so in order to figure this out, let's clean this up a little bit. The first thing that we can do is we can do 9 squared. Okay, so I'm going to rewrite my problem here, but I am going to change 9 squared to 81. Okay. The next thing I would do is I would multiply the 1/3 with the 81, because we can do that. We can get a single number. So again, I'm bringing down the volume. 1/3 times 81 is the same as 81 divided by 3, which is 27. So now what I have on the right side is 27 pi h. Okay, I'm just going to rewrite this up here because I'm out of room to show my next step. Okay, so remember, what we're trying to do is we're trying to solve for the height. We're trying to get h alone. So what I would do next is I would get rid of the 27 pi that's attached to my height. So remember, 27 times pi times h is what's really being shown there. And so to get rid of that, we would be dividing both sides by 27 pi. Okay, by doing that, if you think about it, 27 divided by 27 is 1, so those cancel out. Pi divided by pi is 1, so those cancel out. So we just have the height remaining, which is exactly what we want. So on the other side, what you're going to do is in your calculator, you're going to type in 1441.26 divided by 27 times pi. Okay, so remember using your pi key there. And once you get an answer, you should be getting something like 16.99 for your height. And since it says we're rounding to the nearest centimeter, that means the nearest whole number. And so that would end up being 17 centimeters. Okay, we don't label it centimeters squared, centimeters cubed. It's not the volume, it's just the height. So height is just centimeters. Okay, so tricky, definitely tricky, but again, we've done equation solving before, and this is just another variation of that. Okay, so let's look at number 6. Cone A has a volume of 78.5 cubic inches and a height of 3 inches. Cone B has a volume of 678.24 cubic inches and a height of 8 inches. How much longer is the radius of cone B than the radius of cone A? Use pi equals 3.14. Okay, so a lot going on here. Again, we have two different cubes, and we know the volume of each one, and we also know the height of each one. What we don't know is the radius of them. And so what we need to do is find the radius of each, say which one's longer, and by how much. Okay, so let's kind of split this up again into showing our work like this. All right, and we're going to start with our formula as we always do. Again, just getting this all set up for us. Okay, so let's look at cone A. So it tells me cone A has a volume of 78.5. So I am going to put 78.5 in place of B in my formula. I'm bringing down the 1/3. They tell me that I'm using 3.14 for pi, so I'm going to replace that in my formula there. Remember, the radius is what I don't know, so I have to leave that as r squared for now. But they do tell me that my height is 3 inches. So let's put that in for height. Okay, so just like in the last problem, we have to get all of our numbers kind of combined here. So let's do 1/3 times 3.14 times 3. Okay, so those are all of my numbers on the right side that can be multiplied together. So just kind of thinking through this quickly. 1/3 of 3 is 1, because it's just like saying 3 divided by 3. And so 1 times 3.14 is 3.14. So you should just be getting, when you multiply those three numbers together, 3.14. So now, in order to get r squared alone, we need to divide both sides of the equation by 3.14. That would be the opposite operation. So when I do that, looks like this. So 3.14 divided by 3.14 just gives me r squared. And on the left, if you divide 78.5 by 3.14, you should be getting 25. Just kind of showing my work here now. Okay, so 3.14 into 78.5 is 24. Or 25, excuse me. Okay, so now what I'm trying to figure out is what number squared gives me 25, because it's not just r equals 25, it's saying r squared. So if you think about how to unsquare something, what we're going to do is we're going to take the square root. Now, many of you already just know that the answer is 5, because you're thinking, okay, something times itself gives me 25. Oh, it's 5. But in case we get a number that we can't easily figure that out, what we're really doing is we're taking the square root. And so now I know that my radius is 5. Okay, so we're going to do the same process for cone B. So cone B, going back up to the problem here, has a volume of 678.24. So that's what I'm plugging in for my volume. I'm bringing down the 1/3. I'm putting 3.14 in for pi because they tell me to. And what else do I know? I don't know the radius, so I'm putting radius squared. And then they tell me the height is 8, so times 8. All right, so now on the right side, I'm going to do just as I did before, 1/3 times 3.14 times 8. Okay, I'm getting 25.12, and then I still have the r squared there. Okay, so to get r squared alone, again, it's 25.12 times r squared, so the opposite would be to divide both sides by 25.12. Okay, so these two divide to just give me 1, so just r squared. And over here, when I divide that out, I'm getting 81. So again, to get just r, we have to think, okay, what number times itself gives me 81? Or if I want to unsquare r, I take the square root. And so I'm getting that the radius of that cone is 9. Okay, so it says how much longer is the radius of cone B than the radius of cone A? Well, if I subtract the 2, I'm getting that cone B's radius is 4 inches longer than cone A's. All right, that was a lot of work. Thanks for sticking with me. We're almost there. Number 7. Oscar wants to fill a bucket with water that is in the shape of a right circular cylinder. It has a 6-inch radius and 12-inch height. He uses a scooper that has the shape of a right circular cone with a 3-inch radius and a 4-inch height. How many scoops will it take Oscar to fill the bucket up level with the top? Use 3.14. All right, so let's kind of talk about what's going on here. So we have this bucket. Okay, it is a cylinder, which most buckets are. The reason they say a right circular cylinder is just to show that it's not bent, it's not slanted, it's a bucket standing straight up, which is, again, what buckets usually look like. And then what's happening is Oscar is using a scooper that's in the shape of a cone, okay? And he's scooping water, and we want to know how many scoops is it going to take Oscar to fill that bucket up. Okay, so what we have to figure out is, first of all, how much water can fit into this bucket. Okay, so that's volume, and it's volume of a cylinder. So I'm going to say bucket, just to kind of keep track of what we're doing here. Okay, so if you remember from the previous lesson, pi r squared h is my formula for volume of a cylinder. Okay, they're telling me to use 3.14 for pi. So let's go back up here. It says it has a 6-inch radius and a 12-inch height. So I'm going to do 6 squared times 12. Okay, so let's type this in. We are using 3.14 times 6 squared times 12. 1356.48 inches cubed. All right, so that's how much water will fit into that bucket. Okay, so now let's look at the cone, or if you want to call it the scooper. Interesting shape for a scooper, but we'll take it. So we are going back to our cone formula, which is the same as a cylinder with a 1/3 in front. 1/3, we're using 3.14 for pi. Now let's see, it says the cone has a 3-inch radius and a 4-inch height. So we're going to do times 3 squared times 4. Okay, so let's type that in. You should be getting 37.68 cubic inches. Okay, so we now have the volume for each, and the question is, how many scoops will it take Oscar to fill the bucket up level with the top? So basically, how many times am I going to have to scoop water to fill up that bucket? Okay, so if you think about this, it's almost as if you're taking 37.68 plus 37.68 all the way until you get 1,356.48. Okay, but obviously the faster way to do that is to divide. So we take the total volume of the bucket, and we divide it by the volume of our cone, and we will get how many scoops it will take to fill that bucket up. Okay, so when you do that, we should be getting 36 scoops. Okay, we have one more. You guys are doing awesome. All right, number 8. A cylindrical tank with dimensions shown below contains water that is 1 foot deep. If water is poured into the tank at a constant rate of 20 cubic feet per minute for 20 minutes, will the tank overflow? Use 3.14 for pi. Okay, so we have this tank. It already has a foot of water in it, and we are continuing to fill it up. So what I want to figure out is if this tank is going to overflow if I continue to fill it for 20 minutes, putting 20 cubic feet per minute into it. Okay, so the first thing we should figure out is how much more water can that tank hold? Okay, so it already has a foot deep worth of water in it, and so let's figure out how much more can fit. Okay, so again, this is a cylinder, so we're going back to our cylinder formula. They're saying to use 3.14 for pi. The radius of that cylinder is 3. Now, although it shows our height is 12, remember it already has a foot of water in it, and so when I'm talking about how much more water can fit, I'm going to use 11 for my height because that's the rest of the height that's available. Okay, so if I multiply all those together, I'm getting that I can fit 310.86 more cubic feet. That's the amount of space that's left in that cylinder. Okay, so what I want to figure out now is how much water total is going to be in that tank if I fill it at that rate for 20 minutes. Okay, so to figure this out, I am thinking in my head, okay, every minute 20 cubic feet is being put into that tank. And so if I continue to do that for 20 minutes to figure out how much total is in the tank, I can just multiply. So if there's 20 cubic feet going in per minute and I'm letting it fill for 20 minutes, per minute, I will get how many cubic feet total will be filled. And so 20 times 20 is 400. Okay, so in 20 minutes, I'll be adding 400 cubic feet. Well, is there enough room for 400 cubic feet? No, there was only room for 310.86 cubic feet. So is the tank going to overflow? Absolutely. Yes. It will overflow. All right, you did it. Great job.